All right. Hey, thanks for coming. You must really not have anything to do to come to a presentation on regex this morning. Just kidding. I love regular expressions. I think they're pretty cool. Regex, also known as that weird thing that you have to look up on Stack Overflow once a year, but it's pretty useful when you do.
Who's that? You have it quotes or half a quote.
Well, it was said just now.
He's putting his future self.
All right, so this donuts presentation is going to start out like really theoretical. I'm talking like hyper theory, and then it's going to go pretty practical. Probably split in half, really theoretical and really practical. So let's just dive into the really theoretical part. What is language?
That's creative.
Is there more of a theoretical question, right? What is language? So language is the ability to use and acquire systems of communication. That's just in general what language means. A language would be the implementation of one of those systems, right? So English is a language, but language itself is just using systems of communication, right? So all languages are composed of two parts, grammars and syntaxes. So grammar would be the rules for the structure of a language and how those rules shape the meaning of the language. So the order in which things come can affect the meaning of a sentence. Like it's the difference between dog bites man and man bites dog, right? Those both are in the same format. They have a subject, a verb, and an object, but they mean totally different things, right? That's because grammar. Syntax is more nuanced. Syntax is voice, like dog bites man or man bitten by dog, right? Those both convey the same meaning, but they convey it in a different way using a different voice. That's syntax, so declarative versus imperative, active versus passive. So here's a sentence. When you come to donuts, have a donut. So there's some rules, some grammar rules that apply to that sentence that make it work, that make it have meaning, right? It's in a complete sentence or a complex sentence, which this is an example of a complex sentence. Dependent clauses need to either follow or precede an independent clause. So have a donut, right? You have a donut. That would be an independent clause. It comes right after that independent clause or the dependent clause. So one rule is an independent clause like that has to have a subject, a verb, and an optional object. So I'll just pause now if you guys want to if anybody wants to go. Just kidding. I love this.
There's a back door.
We've got some looks like some students here shadowing. So I'm sorry that you didn't actually get a break from English by coming today, but here we are. So here's two different sentences. Jan walks the dog. Right, so we'll apply a rule, the rule that an independent clause has to contain a subject, a verb, and an optional argument. That would be a grammar rule, right? So we could shorten this rule and create some sort of grammar language, right? To codify this rule in a structure like this. An independent clause has to have a subject, a verb, and an optional argument. Right? This is now a rule which defines one of the grammar rules of the English language, which is a language. So the combination of those symbols that we could use to create a grammatical rule we'll call an expression. So an independent clause equals a subject, a verb, and optionally an object. That's an expression. So languages, there are different types of languages. A regular language is a language that has really well-defined rules that define its grammar and syntax. English is not a regular language, as are not most regular languages. Many spoken languages are not regular because humans. So rules like that they're always ways to bend or break them, right? In spoken languages. So an expression that defines the grammar of a regular language is a regular expression. All right, pivot. So that's grammar and syntax in context of languages, right? So let's hone that down in terms of programming languages. What is grammar and syntax? So programming languages as a language, they have a set of rules or grammars, right, which define keywords, expressions, what characters can appear in what order, and the meaning of those things, right? So the word for in different contexts can have different meanings, right? It could be part of a variable name, or it could be the beginning of a control statement, like a for loop, right? So there are grammar rules which define the meaning of statements and expressions in programming languages. So an example of that, an expression in JavaScript, an expression is anything that you can put on the left of an equal sign. So const a equals b plus 3. So this part here is an expression, right? B plus 3. What's that?
By left you mean right?
By left you mean right?
Yeah. Yeah, the other left.
Clearly.
Yep. Anything on the right of an equal sign. See, but English is not a regular language. So there we go.
Amen.
All right. So to define the rules of grammar for programming languages, we create definitions. And these definitions sometimes are recursive. So an expression, so the equals and then the colons doesn't mean it equals that. It means it could be evaluated as that, right? So an expression could be just an expression. An expression could be an expression plus another expression. It could be an expression minus an expression. It could be a single expression inside of parentheses. Thanks. So these are rules that define the structure of a language, right? So as a language, as programming, your code is being parsed and turned into meaning. There are grammar rules that define that meaning. So programming languages, in addition to rules like that, they can also be shown or defined as state machines, right? Programs take input and they move from state to state based on that input, right? Programs are deterministic. There's no like magical randomness that happens. Even random is, deterministic based on algorithms. So it's possible to take a computer program and show that computer program as a graph that takes input and goes from a start to a finish. So if our input looked like this, AB, a graph that would represent AB, you could start, have the input A to move to a state, and have the input B to move to a state, and then you're finished, right? If your input was A, that would mean there's A, and then any number of A's. So that any number might also be no A's, 0 number of them. Right? So your start and your finish state are the same, and it can take any number of inputs of A. It could take an A or a B and go from the start to the end based on an A or a B input. So there's a theorem that Turing, the man behind the Turing machines and the Turing test, right? There's a theorem that he discovered that state machines are equal to regular expressions. So these are regular expressions. They define the grammar of a language. All regular expressions can be shown as state machines, and all state machines could be shown as regular expressions. So however convoluted, it would be possible to turn any program into a regular expression that defined the input and the output of that program, or into a state machine, like a Turing machine.
Probably be pretty maintainable.
Probably, yeah, I think so. Maintainable. So the announcement, I guess, is our next stack. It's a regular expression-based stack. Yeah. So if we have the input of A, B, and then C, that means an A, and then a B, and then one or more C's. That could be expressed like this. So we have a starting state, we take an input of A, and an input of B, and an input of C, and then you can loop. You can keep having more C's or not, right? But there needs to be one or more, and that's the end of our state, as defined. That machine as defined by that regular expression, which you could also say that language as defined by that regular expression. All right, another pivot. So somewhere along the line, there was an epiphany that you could use these expressions, not just matching patterns of what would be valid input for a state machine, but you could kind of reverse that and say, given a state machine, given a regular expression, let's match what valid input is. Let's look at strings and see if a string is valid input for a regular expression or for a language. So when you define a regular expression for a string, you are behind the scenes defining a grammar for a brand new language that you just invented, that string happens to be a part of. So if you have a regular expression, hello world, that regular expression is a rule for the grammar of a language in which hello world is the only valid entry. So when the string hello world matches the regular expression hello world, what that really means is that string is a valid entry of the new hello world language. All right, so they're regular expressions. Now we're going to move a little more practical. So regular expressions have parts to them, right? So all of the regular expressions look like slash and then some pattern or some string in there and a closing slash. So they're composed of an expression pattern and then flags.
So the state machine, the bubble representation of hello world,
Mhm.
would just be capital H in a bubble,
Yeah,
to the E,
to the E.
to the L, to the L, to the space,
Mm-hmm.
all the way over to the N.
Yeah, well the O before the space.
Yeah, that too. Whatever.
That's a different language.
It's a different religion.
Yeah.
Instead of Philippines.
So hello world with an I flag would be it match exactly hello world in any case. Case insensitive. Hello world with an M flag would be multiple lines or match in multi-lines. Right, these are two examples of flags. There are many different flags. So some regex rules, and we've kind of just shown these. So two things next to each other, an A and a B is an A precisely followed by a B. Right, an A with a pipe in a B would be an A or a B. A star would be any number of A's, including 0 of them. A plus would be at least 1, right? 1 or more A's. A question mark would be a single optional A. If you wanted to use an actual question mark as part of your expression, you'd escape that question mark. So the slash like that escapes is an escape character. So some more useful rules. A period is any character, any possible character. If you want to do ranges, like say any valid letter, lowercase would be A through Z. There's A through Z uppercase. You could do 0 through 9, which would be any digit. A slash D would be not a range of digit, but any single digit. Right, slash W would be any single word character, which is alphanumeric. So slash W would match any lowercase or uppercase letter or any digit. All right, and some more useful rules. The beginning of a word, the beginning of a string is a caret. The beginning of a word or the end of a word is a escaped B, so a word boundary. So that could be basically anything that precedes or follows a space character or like a new line character. If you want to group stuff together, you can use parentheses. And if you want to find something at the end, the $sign. And these are like, I don't know if anybody's memorized these, so they're cheat sheets. If you need to write one, you just pull up a little cheat sheet. All right, so we're going to build one together. So there's a handy tool called regexer.com, which you can type in any regex pattern, and then it will evaluate it live and show you matches to that pattern. And so we wanted to match dates in this format. So that would be a month / day / year. So if we want to build one, let's first make a little test case. So let's erase this one that was in there. We'll create a test case. So we'll do, the example in there was Christmas. So if we wanted to match this, just if this was our only test case and we wanted to match this exactly, what could we use? What are some things we could use to match that? Yeah, in the back.
Exact match of it. 12/25/.
Oh, yeah, an exact match, like a literal exact match. Okay, great. So if we wanted to make it more general, to match any, you programmer, any class of date that followed these number of digits and slashes. Yeah, go ahead.
Well, for some of the dates, we put a range for them, like for the months, 1 through 12, for the days, 1 through 31.
Great idea. Great idea, yep. So you could use a range. So this was our range right here, 0 through 9. So this one only allows us to do these digits, 0 through 9, right? So we couldn't do 0 through 31, but we'll do something really similar, and we can use this any single digit one right here. So we'll replace this and go a digit, and so we have 2. It matched all the possible ones, right? So you can see those are broken up a little bit. The 12, 25, 20, and 17. Those are all matches. So if we wanted to now match larger, we'll do a slash. So there's our 2 digits with a slash, and then digit. And I think I'm missing a slash in there. Let's see, a digit with a slash. There you go. So this matches now anything that can have, so 2 digits slash 2 digits slash 4 digits, right? This is pretty repetitive.
But that also isn't going to get it. Say it's December 3rd. and
Sure.
It's not, the 3rd is 03.
The 3rd is not 03, right? So we have a couple problems. So it's repetitive, and
Or you could have the 52nd month.
or the 52nd month, or what did you say? Say it again.
Single digit.
A single digit, like January, right?
January, the 3rd of the month.
Okay. So let's look back at our rules and find. So we want to do. We want to have. Maybe instead of a digit, we could do a single optional digit, right? This will allow us to do, like, optionally there's 2 digits, but there has to at least be 1. So a digit question mark. So we'll have optionally, yep, so we need some more test cases. So let's do 3, 12, 2017, and we'll do 12, 1, 2017.
I would say do the first 2 in the year because you could also have, 12, 1, 17.
Oh, so if you wanted to just leave out the 2017,
No, just the 20.
or leave out 7, so it'll just be a /17.
Yeah.
That's if we're dealing with dates from 1017, we don't want to be ambiguous. So we'll make sure that has to be 4 digits. Although we could do that. All right, so these two are repetitive, right? There are 2 exact copies of that pattern. Yeah.
I think the difficulty with this depends on how accurate you want this to be.
Sure.
If you want to get into, okay, well, make sure it's only number 1 through 12.
Yeah.
That's a little bit difficult. Well, now you want to have the range of the day depend on the first group.
Yeah, like 30. Like some months have 30 and some have 31, and
Take in leap years. And
sure.
millennials, whatever they are.
Yeah, that's a problem that's probably not solved by regex.
And there's
That's more of a
some
business problem.
European style doing day, month, year.
Sure. Yeah, that's a business rule problem, I think. So have different validation formats, right? Or different types of input. So we'll just solve for this class of input, not knowing the business rule that there's not 13 months. So that's repetitive, right? There are 2 copies of that precisely. So we want to have 2 of those. We'll go ahead and erase this one. So now it's just capturing the last half. But we want to group them together. So we'll create a group. And then we want that group to repeat 2 times, right? Do you have a question, Jared?
No.
Okay. So I don't remember what the repeat precisely 2 times is, and it wasn't in there. Curly brace. So we can look up here in our reference. So this tool has a lot of cool stuff over here. There's a whole reference guide, so you can look up. So character classes, no. Let's see, probably groups. Is it in here? Cheat sheet, maybe that's it. Yep, between 1 and 3, so we want to do curly braces, right? So we'll do precisely 2 times. So we could also, that means we could shorten this part too. We want to have this repeat exactly 4 times. So let's turn one of, see, I don't know if we need to group it. So this is, can we, without going into the business logic, just matching the pattern of the text, any other ideas we can make that more concise or, yeah.
You can do the parenthesis 1, 2 to say it has to repeat 1 or 2 times. So in the, you can take
right
out
here.
all the dash D's in your parentheses.
So 1, 2. Cool. So have 1 or 2 digits exactly twice, and then have 1 digit exactly 4 times, or 4 digits. Cool. I like that. All right. So here's our pattern. All right. So this is what I came up with. Oh, here's a test case we didn't think of. Right. What if so that's not a valid date. There are too many there. So let's put a word boundary in front. So it has to follow white space. You probably put one at the end too. So it has to end with white space. So
word boundary, not start of string.
So start of string would be the caret. So now you can only find 1, right? And only if it's at the very beginning of the string. So we don't want to find things just at the beginning of strings. We want to find things just at the beginning of words or the end of words. So we'll use that word boundary. So the different parts of this. So a beginning of a word, a group of 1 digit and an optional digit with a slash, which we shortened to just have I don't know if that was actually any less characters, but it looked cooler to be 1 or 2 digits optionally.
That's what we're worried about here.
Yeah. Repeat it twice, followed by 4 digits. All right, so this is kind of a breakdown of that regular expression. So let's do another one. Let's match emails of a certain domain. All right. So the email address was, for our test case, okay, so we'll start simple, right? We'll start just by doing our test case, and then we'll build on that. So to match this, we know we're going to have basically some text followed exactly by that domain. So we'll just start with the exactly that domain part. There we go. All right, now the part of matching some text. Right, so we want to have this just contains just contains letters.
I want to escape the dot too.
Oh yeah, because that would be LDS Church any character org.
Would you want to escape the at character?
At's fine because there's not a corresponding regular expression at rule. So yep, good idea. We'll do word boundaries. So this matches our string, But this is a pretty narrow definition of an email address, right? So if it was like that no longer matches. It also doesn't allow dots, right? There are different things. So instead of any character, let's do any valid word character, which is alphanumeric. So this doesn't allow dots though. So this is also a valid email address.
Do you own all of these email addresses?
Yeah, spam them all. So if we wanted to do that, let's do something like we'll have any word characters repeating, but it could also be or a period. So any word character or a period repeating.
Word character match on underscore.
Yes, it does.
Jasper is going to be a problem.
Yep.
Should be brackets.
Brackets. Well, this is a. They could be brackets.
Maybe don't use the or.
Yeah, good idea. So this doesn't. One of my favorite uses for email would be. So I can sign up for stuff using, like, this spam filter. Yeah, Jared.
That would also, if your email started with a dot, that would be a problem.
That would be a match.
Yeah.
So it found that because a period is a valid word boundary, right? So maybe in space of a word bound, let's say a word boundary or a white space character.
Jasper would be an invalid email, right?
Yeah, this should be an invalid email. So word character, one or more word characters, plus that with the beginning of a word. So it matched. It didn't match the dot. Yeah,
Here's an optional dot
an optional dot.
at the front, in front of your
What David put one right here.
period slash pre-question. You don't want that? I thought it was valid. Oh, it's not.
I don't think it's valid. Well, really, what is valid email addresses is quite complex. We're not going to cover. I think this is fair. This is good for this demo. All right. So word characters with a period or a plus at here. If we wanted to do multiple domains, maybe say we had like internal domains or external domains, right? You could say org or net, right?
Make the church optional.
Make church optional. So 0 or 1 of them.
Left that on the outside, for instance.
Yeah, thanks. Yeah.
Would you be able to make it so after the at it would say any combination of letters stop working at?
Yeah.
Because then you could have a more broad variety.
Any email address, right?
Yeah.
So you could repeat, if you want to do this, right, repeat what is a valid domain. A valid domains would be, there's rules about what a valid, after the at sign would be. You could just replace this whole entire thing with what would be a valid after the at sign. That's a great idea. So in our case, this is pretty close to what we built. This is actually worse. I think we made a better one just now. So a word boundary, groups of characters, digits, a plus sign, or a period. That string, and then some strings for possible domains, right? Or possible different domains. So the actual email address one is bigger.
It doesn't even include Unicode, does it? Because you can have Unicode domains.
Yeah, I don't think this includes Unicode domains or IPv6 addresses.
For those who want to laugh at it, it's like 2 pages long.
The regular expression for the RFC. Yeah.
It just as a regex was generated to apply all of the rules.
I think any string that contains an at symbol is technically a valid email address.
That's a much
Just about,
simpler
right?
regex rule.
I guess that would be a simpler regex rule, right? All right.
Dot plus at dot plus.
So let's do another one. Say you have you're doing like a mail merge thing, and you want to get all of these different groups and pull them out to do a mail merge. So here's our all right. So hello name. So what we want to do is we want to capture what's in between here. So let's look back at our rules. We did a little bit about capture. So we group stuff. This parentheses is also a capture group. So let's use that to our advantage. So we want to do anything that starts with a $sign and a open bracket. And then we want to capture something that has one or more word characters. And then end with a closing parenthesis. All right.
Is the curly a word character?
No, I don't think curly's. Are curly's word characters? I didn't think they were.
Alphanumeric underscore.
Can you have it
No.
so the selection actually excludes the dollar?
So this just shows what matches, right? But the capture group is just what's inside there. So we can look down here at the bottom where it says tools. So we can look at the list. So here's a list of those capture groups. So it just pulls out name,
What's the piece that does the capture?
the parentheses. So the first set of parentheses will be your first capture group. So if you were writing like a spam email bot, right, you could use this to do some sort of mail merge. If you didn't want to use like a professional, robust mail merge tool.
I want to roll my own.
Yeah, roll your own mail merge. Or roll your own string replacement, roll your own templating library. Yeah. A laugh, that's the appropriate response to roll your own string library, or a templating library. All right, so this shows, though, that you can capture, right, from this string. We didn't just find certain things to see if they matched or not. We actually pulled data out of it, right? So it matched, and we pulled data from there. Let's see. So here's that rule. Right, so a $sign and a curly brace with a capture group with one or more word characters followed by a single curly brace. Right, and you saw that captured down here that different data in there.
Does your
In that group.
tab also lay that out for you?
Cool. This is such a great tool. I think this is like one of the best free website for utilities, like free utility thing. It's awesome. And there's no ads anywhere. I don't know how they run it.
I'm sure that's not your ad blocker.
Like I said, I don't know how they run it. All right, so this is just showing the use of regular expressions. Regular expressions, as implemented in different languages, vary. So, like the rules, like between these, the helpful, these things, these can be slightly different from language to language as they're implemented. And so, if you understand regular expressions and know them well in one language, the rules for how that regular expressions are, or how they're implemented in other languages may be slightly different, but the ideas are the same. And so here's using them in JavaScript. So regular expressions are pretty cool. They're a primitive data type. So other examples of primitive data types include number,
String.
null, string, Boolean, right? That means anything that's a primitive data type means you don't have to like encapsulate it in an object. You can just say a variable equals false, right? Or a variable equals a number. So regular expressions are primitive data types in JavaScript. You could say this expression equals, and just type out the expression. There is a constructor function if you want to use it, but you can. But there's I don't know if it actually does anything of value, right? There's a primitive
Variable based.
or a variable-based regular expression that allows you to do it. All right. So you can, for the most part, you can, if you don't need something super complex, you can just put your regular expression like that as a primitive data type. So if you wanted to test a string against that expression, these primitive data types have built-in methods, right? So you could say .test and pass it a string. That would evaluate to true. You can also, I kind of think that syntax is awesome, right? Because it's a primitive data type, you can just put a method right on the back of a regular expression. Say regular expression .test a string and see what that evaluates to. So methods that use regular expressions, right? There are regular expressions themselves have methods, and then there are other methods in JavaScript which accept regular expressions. So a couple that regular expressions have are test and execute. So if you test the regular expression hello world against the string regular or the string hello world, is found will equal true. So you can use this execute function, and it will return an array which contains data objects. It'll return what it found that matched, and the index it found it at, and the input of the input that it accepted. This just happens one time. So if you have a string with lots of these things and you want to find all of them, you can write a while loop that says while regular expression dot execute the string, and then output that data or save that data to an object or an array or something like that. So some methods that use regular expressions that are not necessarily on the regular expression data type, right, that object, so are mostly strings. In fact, I don't know any that aren't. I think they're all strings that use regular expressions. So if you had a string, hello world, you could match it and pass it the regular expression world. That would return to you data, which described the match and the index where it was found, and the input that was passed. It operates, I think, the same way, or it gives you back the same format of data as execute. So search will return to you only the index of where it was found. Replace, remember strings are immutable, right? And so you'd have to assign this to another variable. So you could replace world with everybody, and it would return the string, hello everybody. You could also split, yeah.
In search, if it doesn't find something, does it return -1?
I believe so, but I haven't tested that. Yeah, I think it is. I think it would work under the same return results as like index of. We could test that. All right, and then you could split. Right, so split. You could split using a string. Like if you had a sentence you wanted to split into words, you could pass it as just a space character inside of a string. If you wanted to split based on a regular expression, you can pass it a regular expression. So in this case, we're passing it a regular expression of a space character.
Can you do the capture in JS?
Yeah, so capture would work with, that would be like execute.
They replaced it.
Or replace as well. Cool.
The dollar reference to the match.
All right, so for the last 15 minutes, I will attempt to live code something that uses regular expressions that's useful. So the common uses for regular expressions would be like validating an email address, validating a password, like is a strong password or not, validating phone numbers, anything like that. So what I'm going to do just in 15 minutes, hopefully less, is also a little teaser for our React class. I'm going to write a React component that uses a regular expression to validate its input, and we'll do a password field. So I haven't set this up at all. Let me go ahead and add some CodePen stuff that will make it so we can do React right in CodePen.
The template.
We're going to have a spot on our page where the React app can inject to. Let's extract React and React DOM from the window object. All right, so we're going to use ES6 class syntax because this is. How's that? A good font size for everybody? Better? Anybody want a larger font in the back? How's that? One more? That's good? Okay. I couldn't interpret that is yes larger or it is appropriate. Alright, so we're going to use the ES6 class syntax for React. So we'll call this one password field. Alright, so we're going to do some React boilerplate here. We're going to create a constructor. And our component is going to have some state. It's a password field, so it's either valid or not valid, whether it is a strong password or not. And by default, we'll have it be false, so it's by default not a valid password. Thanks. Okay, now we want our React component to render out something, probably an input box. There's a password type, but I want to use the text type for now, just so we can see. What's that?
See what's going in.
Yeah, so we can see what's going in, right? A little easier just to test against if it's a text type. Okay, and now we need to actually put this on the page. So we'll call React DOM and render our component. And we want to render it to that div that I created in the HTML spot. Okay, yay! An input box. I was nervous that's going to work or not. Live coding. Alright, so this is just an input box. It doesn't really do anything. We want to have a method that's called to do the validation, and we want that to happen whenever there's a keystroke, right? So we're going to create a new method here in our component called validate. And it's going to accept the event, right, that key event as we're typing in. And that means we're going to have to call it here on change equals this dot validate. And I have to do a little bit of boilerplate to get this function to work in this React component with the scope of the component. Okay, so just to test to see if this is working or not, I'll log out the value. So whatever event happens, we're going to look at the target where that happened, which is like the DOM element, right, that the event happened on, and log out its value. Okay, so let's open the console here and type in this is a test. Cool. So that works. So we're getting the value there. So now we want to create some sort of validation rule, whether that's a valid password or not. I don't want to write one right in front of everybody, so let's go look at regexer and find examples. Let's see, or let's go back. Where's the community one? Oh, there's community. Yeah, this will be password validator. We'll find one that somebody else wrote. Let's see. Password should be at least one capital letter, one small letter, one number, and 8 characters in length. That sounds good. I didn't want to write this. It'll take up the rest of the time, I think. So instead of logging out the value, let's create our, so this is our test, right? So this is our test that we're going to test against. And now we can say test dot, and let's look, because we look every time what those methods are. Is it test dot test? So to prevent redundancy, I'll call that rules. Rules.test. And the thing that we're going to test is the input. That's the thing we just logged out. So we'll test event.target.value. And we'll assign that to a variable is valid. Okay. So we have this state up here. We're keeping track of if our component, if the password is valid or not. So we want to change that. So we'll just call this valid, and we'll say this dot state. Yep. So we're going to use some ES6 object construction here, because this is just this valid field, a key and a property of valid. We'll just set the state to valid, and that's going to equal true or false right there. So we now have this being true or false, is valid or not valid, but that doesn't really do anything for us. Let's have a visual indication. So let's have a visual indication using classes. So a valid should have a green border. And no outline. Yeah. And then a red border on an invalid one. Okay, so now we need to change the class. So on our input element, we'll set a class name, and that class name is going to depend on the state. We'll use a ternary operator. This dot state dot valid. I like to read those like a sentence. This dot state dot valid. If so, then the class is valid. If not, then the class is invalid.
Oh.
Yay! Jared had the suggestion, why don't we give a little text hint as well? So we'll put that, we got another 5 minutes, we'll add some text here. So we'd say, we'll do the same thing. This dot state dot valid, and we're going to use a logical operator or and, excuse me.
On the left side of the
On the left side of the equal, and so if it is valid, let's see. So we'll just give a message if it's not valid. If it's not valid, we want to tell them why, right? So if it's not valid, we'll say password must contain 8 characters, 1 uppercase letter, and 1 number. At least, right? There you go. So now as we go back and forth, right, so now we have live validation, and it's updating live because of the awesome stuff that React gives us. Any questions about this before I switch back to the very last slide of this slide deck? So this is a little teaser for our React training. If you guys want to know more about React or how to write components like this, sign up. We'll have another training Jared mentioned next month. We've offered a couple. We have one scheduled that I think it's sold out in like 48 hours or something like that. So if you see another email and you want to come jump on that, yeah, go ahead.
Just a comment. Be careful when you're pasting things from the internet with regular expressions. A good example is this one. For those who are familiar with flip arounds, what the one basically actually does. It actually, at the end of these look aheads aren't actually consuming it as the dot star at the end. So it will accept anything as long as it matches those rules, which means you could probably do some SQL injection.
Sure.
You would want to replace that dot star at the very end that you got
Uh-huh.
with basically one or more of letters, numbers, underscores. And just say we're confined to this.
Sure.
We actually go through it after it's validated all the
Yeah.
tests with the previous ones. So
Good.
Just something to bear in mind.
Yeah.
With the bigger ones.
Good point. So the point was, if you don't look at the regular expression closely, you don't know what it's actually validating. Right, so this only validates the specific rules, 8 characters, one of them has to be, or 8 characters or more, one of them has to be uppercase, one of them has to be a number. Right? So your point was, it could be a SQL injection. So I would suggest, if you're worried about validating SQL injection, you probably need to have parameterized queries on your back end. Passwords should be able to contain SQL statements to be really strong passwords, right? Yeah.
That's my password.
Yeah. It's gonna get hashed and salted and right. But so you should always parameterize your queries. But I think your point is still really valid, that you don't know what it does unless you know what it does, right?
But it says it.
Yep. All right, and that's the end, or is it the beginning? Thank you.